Good day. My name is Mohan Kumar, and today I'll be presenting my research project titled Mqtt-Apex, an adaptive capability aware security framework for MQTT based IoT systems. This work addresses the limitations in existing MQTT security models by introducing tiered dynamic security that adjusts based on the device capacity. Security gaps in MQTT based IoT. MQTT is popular lightweight messaging protocol used across many IoT deployments. However, its standard security models are often static, treating all devices equally regardless of their constraints. That cause over securing of low end devices and under securing of the powerful ones. Many frameworks rely on TLS alone or assigning fixed roles that do not adapt over time. There are also a minimal integration between device profiling and policy reinforcement. Goals of MQTT Apex. MQTT Apex was designed with four primary goals in the mind. First, we wanted to enable per device capability assessment, looking at things like CPU, RAM, and power state. Second, we designed a tiered security system that maps a stronger lightweight mechanism depending on what a device can handle. Third, we introduce a dynamic ACL access control list that adjusts automatically as devices join or change. And finally, we maintained a strong focus on usability, ensuring that constrained devices aren't excluded due to the performance overhead. MQTT Apex framework components. The architecture has four major components. First is the tier engine, which assigns a security tier based on the device capabilities. Second is a Flask-based web application that handles device registration and credential issuance. Third is the Mosquito MQTT broker extended with plugins for access control list and tier validation. And lastly, we have a simulated environment that mimics class 0 to class 2 devices for testing. Multi-tier security structure. The framework defines three-tier architecture. Tier 1 is the most secure using TLS 1.3 and mutual certificates based authentication by incorporating X509 certifications. Tier 2 uses the TLS 1.2 and JWT web tokens for authentication. Tier 3 uses TLS 1.2 with pre-shared keys which are lightweight and suitable for very constrained devices. Tier assignment is automatic based on the threshold defined in terms of CPU frequency, RAM, and power profiles. Policy enforcement mechanism. The enforcement process is fully automated. When a device is added, it assigns a tier and credentials. The system regenerates access control list based on the new state or reloads them in the broker without disconnecting active clients. Each device is only allowed to publish or subscribe to topic it has explicit permission for, and also access is tier aware. Administration control panel. The dashboard provides an easy to use interface for managing devices. Uh, you can register new device, edit existing profiles, and monitor activity in real time. WebSocket integration ensures that update, status change, and error logs are pushed instantly to all connected clients, giving administration full visibility into security landscapes. Simulated IoT device behavior. To evaluate the framework, we created simulated device that mimics realistic public rates, resource constraints, and error patterns. These simulations helps us test how the system performs under load and how well it handles threats like replay attack or malformed payloads. We used Docker containers with throttled CPU and RAM to emulate different classes of IoT hardwares. Robustness against threats. Across multiple threat classes, Mqtt-Apex perform well. It blocked all 50 authentication bypass attempts and 100% of message replies were detected. DOS attacks were mitigated with 95.9% success. Only one known weakness is payload injection. It only detects 88% and due to the lack of deep packet inspection. Still, this shows the framework handles identity level threats very effectively. Comparison with existing frameworks. When compared with existing frameworks, the one using fog layered brokers and another multi-layered model for healthcare, MQTT Apex stands support. Both baseline system lacks dynamic testing and do not reassign policies based on the capability changes. Only MQTT Apex offers real-time ACL generation, tier-specific protocols, and per-device security configuration, all with minimal manual interventions. What's missing and what's next in the MQTT Apex? All tests were conducted in simulated environment, not on the real hardware. We didn't evaluate stability over long uptime, nor did we explore advanced threats like cross-broker spoofing or MQTT 5.0 property abuse. Future work includes testing on ESP32 device or STEM32 boards, integrating ML-based anomaly detection, and adapting MQTT 5.0 features for richer diagnostic and controls. Final takeaways. To conclude, MQTT Apex introduced an adaptive model for securing IoT device using MQTT. It tailors security mechanism to device capability, automates enforcement, and provides real-time feedback to administrators. While it's not yet production ready, this work offers a strong foundation for scalable, capability aware IoT security. Thank you. Let's start by adding a new device. Let's directly jump into the demonstration. Let's uh, start by adding a new device through an MQTT Apex dashboard. This is the dashboard layout. So we can see different metrics from this dashboard. So for now, I'm going to give a simple uh, tire assignment workflow by adding a device into the framework. So let me add a server. It's an edge. Let's consider it as an edge server, server 101, and make sure it's a server. And let's say it only has 600. It is only capable of 600 megahertz of CPU frequency and only have the 128 of inbuilt RAM. And let's give storage and make sure it is battery powered server. So let's enable all possible cryptographic supports by this server. I'm clicking every cryptographic support for this server, and I'm adding the device to the list. So if you see, the server has been added to the device management console, and we can able to see its profile. So we can explicitly see what are its capabilities, and we can able to see its credentials as well. So now it is assigned with tier 2, and it has its own tokens as well. So if we like to edit its capability maybe in future, if we are like to switch server with others, upgraded version of it, and let's say we are adding 900 megahertz frequency, because if it's more than 800, then it would be, by default it would be added into tier 1 framework, and the RAM is more than 256, let's say 512 MB of RAM and 1000 MB of storage. And it is powered by main. So we already gave the supported cryptographic, so we doesn't have to change anything here. If we click save changes, the device was updated successfully in the backend, and if we see this information, it will be assigned into tier 1 by default and it is active. So these capabilities of assigning different tires and regenerating ACL based on the tire on the fly without connecting any devices is not discussed in any baseline frameworks yet. So I will show you the I will show the uh, test script we are going to run. These are the logs running on the Docker container. Now let's run a quick security test to check its uh, capability of uh, detecting the threats. So it will start this simulated real world test vulnerability assessment where it it try to bypass security. I try to start DOS attack and try to inject a malicious payload into the message packets. So let's see how our system is going to respond for these 6 different security threats. So if we see in the dashboard, we can able to see the rise in the security events graph, which is the recent security events were tried on this uh, broker. So the plugin itself able to detect and prevent the identity and access control list breaches beforehand. So let's give it some time to completely run execute the security test. So if we can see the broker is denying a request from unauthorized devices, and the same is reflecting in the security events in the dashboard as well. So in meantime, we can discuss about the threat classes. So it's the security test script is consist of 6 different threats simulation. So first one is auth bypass. So authentication bypass is carried out through this class. And if we move to next, it has unauthorized access test where we are trying to access the uh, restricted topics which are not available for the unknown anonymous devices. So these are the topics it's available in the broker for tier 1 and admin privileged devices, not for the anonymous one, but we are try to crack those topics and try to publish messages from try to publish the message to the topics. And DOS attack, we are simulating a repetitive message burst into the attack, and we also testing against message replay test. So we can see the test result in this section. So uh, it it successfully detected most of the 6 different security threats and it able to prevent it from descripting the MQTT broker. So So that concludes the demo. We saw how devices are assigned tires based on their profiles, how the tire adjusts dynamically when capabilities are changed, and how MQTT Apex actively enforce authentication and ACL rules in real time. Thank you.